Hi ladies, in this video we're going through 5C, which is factorising monic quadratic trinomials. So monic quadratic just means that you've got a quadratic where the coefficient of x squared is 1. So they're the easier ones. Whereas later on we'll be doing non-monic quadratics. So your coefficient of x squared is not 1. Okay, so these are the easier ones. When we get to non-monic, slightly harder. All right, so the second dot point in your key ideas, which you should be putting into your bound reference, is that monic quadratics of the form x squared plus bx plus c can be factorized by finding the two numbers that multiply to give the constant term, c, and add to give the coefficient of x. So you can just, let me just get my arrow. So you're looking for two numbers that when you multiply them together, they give this number here, which is in this form represented by C, and add to give you B. Okay, so the coefficient of X. So that's basically what that means. So in a previous video, I think it was in 5A, we kind of did something similar, but not exactly the same. So this is just factorizing by kind of finding, well, two numbers that multiply to give you the constant, the C, and add to give you the coefficient of X, which is your B. Okay, so let's look at question 2A. Okay, so we've got x squared plus 7x plus 6. So we're looking for, and you can set it up like this if you like, we're looking for two numbers when multiplied give you 6, and those same numbers, when you add them, have to give you 7. Okay, so two numbers when multiplied give you 6, and when you add them, gives you 7. Now, it's always easier to think of the factor pairs of 6 first, and then dealing with the 7. So if you think of the number 6, you can have the factor pairs, you can have 6 times 1, you can have 3 times 2, and you can also have negatives. So you could have negative 6 times negative 1, you could have negative 3 times negative 2. Okay, so sometimes you would need to deal with the negatives. Now, it would only be negative if the number in the middle was a negative. Okay, so you need to remember that. And if your constant was a negative, then one of the numbers would be a negative. And that might make more sense once we start doing examples. Okay, let me just get a different color. I don't know why I just felt like a different color. All right, so you can say, let's try our first factor pair, 6 and 1. So if I put 6 and 1 here, I know it equals 6 because I've just tested it out there, but it also has to be the same here. So does 6 plus 1 equal 7? Yes, it does. So when I factorize, and I always set it up when I factorize, I put my x's in, I just do that. And then I say, all right, what are my numbers? My numbers are 6 and 1. So plus 6 plus 1. And if you like, you can expand it, because remember, expanding is the opposite of factorizing. To check your answer, it's very time consuming, and I'm not going to do it in this video because I'm sure this video is going to be long enough. All right, question B. We've got x squared plus 5x plus 6. So some people would be able to just look at those two numbers and know what it's going to be. So let me just change back to black. Okay, so we need two numbers when multiplied gives you 6, and when added give you 5. And well, we kind of did that before. So for the 2A, we had the constant was 6. Okay, I'll just scroll up a bit more. Now let me scroll. There we go. So remember we had 6. We've got 6 again. So I kind of done the working out here. All right, now we know we already used 6 and 1, so let's try 3 and 2. So let's change to green just because we can. Okay, so I know 3 and 2, 3 times 2 is equal to 6. And when we add them, we get 5. So when we factorize that expression, we're going to have x plus 3, x plus 2. Now it doesn't matter your order, remember, because we're multiplying. So that is the same as x plus 2, x plus 3. Doesn't matter what order you put it in, okay? It's the same thing. All right, let's scroll on to question 3. Question E. 2e. We've got x squared plus 7x plus 12. All right, the same thing. Two numbers when multiplied gives you 12, and when you add them. Now you could do this in your head. You might think, well, if I did 12 and 1, that's not going to equal 7. 6 and 2 is not going to equal 7. Let's try 3 and 4. So 3 times 4 is equal to 12, and 3 plus 4 is equal to 7. So factorising that is going to give you x plus 3, x plus 4. All right, I'm not going to do f just because the video is long enough. So let's move on to question 3. Okay, so we've got 2x squared plus 14x plus 20. And the question has kind of given it away, taking out the common factor. Now, you should always take out a common factor if you can. And so at the moment, you can see it's not monic because the coefficient of x squared is 2, but we can take out the common factor of 2. Now that makes it a monic. Okay, just make sure that you factorize the other expressions too. So that's 7x, and then we've got, excuse me, you should be 10, and then close the bracket. So you can leave the 2 there. Remember, we're going to have 2 brackets because we're factorizing. All right, so 2 numbers that multiply to give you 10 and add to give you 7. So those 2 numbers are going to be 5 and 2. Okay, so remember, like I did before, you can write them all down, but sometimes they're easier just to do it in your head. Okay, moving on. Question B is quite similar, so I'm going to move on to question 4 now. All right, so this time we're factorizing using perfect squares. Okay, so it's kind of hinted to us, if it's a perfect square, that means that when I factorize it, your number here is going to be the same as your number here. All right, so that number obviously is going to be 2. Okay, because 2 times 2 gives you 4. But just be aware of this sign here, because if I made them both plus, that should be a plus 4x, but it's a minus, so we've got to make that a minus 2. Okay, so if I was to expand that, x times x gives you x squared, then minus 2x plus 4. Okay, so always take note of your sign. All right, let's have a look at B. So we've got x squared. Here we've got a plus. Okay, so that tells me that they're going to be positive, whereas before, because it was a negative 4x, it was going to be a negative. So let's just go, oops. Can I just show you that I wrote, that should be finished like that. Okay, so factorizing it completely, because they're the same, I can just rewrite them as x minus 2 squared. All right, so moving on to B, right, drawing my brackets. Anyway, so 9, what 2 numbers multiplied by each other give you 9? They're 3, it's 3. And we've got a positive 6, so it's going to be plus 3 plus 3. And because they're the same, we can rewrite that as x plus 3 squared. All right, I have just had to cut out all of question 6, so you don't even know, but I just did question 6, and I, first of all, didn't write the whole question down, and when I got to the end, I noticed I made a small mistake, and I decided just to do it all over again. So if it seemed like I had a little glitch in the video, that's because I had to delete what I had done, and I'm going to start again. So first of all, I wrote this question down and I forgot this second fraction. Then I went back and did it, and then I realized my answer was wrong. And so I made the decision just to start again. Okay, so yeah, I think it would have been quite irritating for you to, or frustrating for you to get to the end and then realize I'd made a mistake. Okay, let's do each part on its own. So we've got x squared minus 4, then we've got x squared minus x minus 6, and then we've got the fraction over here. So let's just do each part slowly so we don't make mistakes. But I can't fit in a lot of working out, but I'll explain what I'm doing. So x squared minus 4. What we've got here is the difference of perfect squares. So we did that in the previous video. So if you want to go back to your notes for that, you can. But basically, we're going to have x plus 2, x minus 2. Okay, so that's using the difference of perfect squares. For your denominator, we need two numbers. When multiplied gives you negative 6, and when added gives you negative x. So, oh sorry, negative 1. There's an imaginary 1 there. Okay, so we're going to have, all right, so our two numbers, one of them has to be negative because of this negative sign, and the difference has to be negative 1. So I know my numbers are going to be 3 and 2. And the negative is going to be with the 3 and the positive with the 2. Okay, and if you need to double check, you can quickly expand that in your head. And that's where I made the mistake in the previous video. All right, when I'm factorizing this, I take out the common factor. So you can see 5 is common to both 5x and 15. So I'm going to take that out. And this question is designed so you can start cancelling things out. So you can see you've got an x plus 2 will eventually cancel out with this x plus 2. This x minus 3 will cancel out with this x minus 3. So we're on the right track. All right, so your denominator, two numbers when multiplied gives you negative 12, and when added gives you 4. Now I know one has to be negative and one has to be positive because you've got the negative 12 here. And I know my numbers are going to be 6 and 2 because when I do positive 6 minus 2, I get 4. All right, we're multiplying these together. Now you can, and I'm going to do this just so I can skip a step, start cancelling some things out. So anything on the numerator, because when we multiply, all the numerators get multiplied together, and all the denominators get multiplied together. So anything that is on the top, either on the left-hand side or the right-hand side, can get cancelled out by something on the left, on the denominator on the left-hand side or right-hand side. So I've got x plus 2 here. That's going to cancel out with that x plus 2. Now this x minus 2 is going to cancel out with this x minus 2, and this x minus 3 is going to cancel out with this x minus 3. So effectively, all I am left with is this 5 and x plus 6. Okay, so all that working out for such a simple answer. Okay, so let's do C as well. So I'll do that on the next page. And I must admit, I've never cut a video and inserted a new one. So as I'm talking, I'm secretly hoping that everything works out because it's a lot of time to do these. And I don't usually, sometimes I waffle on and I'm like, oh, it's not very professional. I don't really care about if it's professional or not, but I do want to make sure that if I make any major mistakes that I don't continue. Okay, so I'm just checking that I've copied it correctly because sometimes that's my mistake, my error. All right, so again, doing each part separately. So let's look at this numerator first. So two numbers when multiplied gives you negative 3 and when added gives you 2. So that negative 3 tells me that one of them has to be a negative. Okay, so you can make that second one negative if you like. And I'm going to do the numbers 3 and 1. So positive 3 minus 1 gives me positive 2. Okay, so x plus 3, x minus 1. Then the bottom, you've got difference of perfect squares. So that's going to be x plus 5. So the 5 comes from the square root of 25. If you're unsure what I'm doing there, go back and watch the video on 5b. All right, so this numerator, take out the common factor, which is 2. So we've got x minus 5. And then, oh, we don't have to do anything with the x plus 3. How awesome. All right, so let's cancel. Remember, we don't have to multiply them all together now. We can kind of know that, the numerators are all together when we cancel out with any denominators. So this x plus 3 cancels out with this x plus 3. We've got x minus 5 here. That can cancel out with that x minus 5. So we're left with, on the top, 2x minus 1 over x plus 5. And I'm going to just pause to make sure that's correct. Hopefully it is. All right, good. It's correct. Let's move on. Okay, question 7. Give me my red pen. Okay, so 7a, we've got x squared minus 7 over x plus root 7. Now, this is the difference of perfect squares again. So in the previous video, do watch it if you have forgotten. So we're going to have on the top x plus root 7 times x minus root 7. And that's all over x plus root 7. So when we simplify it, we can cancel out the x plus root 7, and we're just left with x minus root 7. All right, and then the second one is pretty similar, but let's do it anyway. So x squared minus 10 over x minus root 10. So difference of perfect squares. Getting a bit sloppy with my drawing or my writing. Okay, so then we've got x minus 10, root 10 on the bottom. You don't necessarily have to put that in brackets, but I will because why not? And then we've got x plus root 10 we are left with. Okay, I think that's it. Let me just quickly scroll. Good. All right, bye girls.